So last lesson we looked at tree diagrams, drawing tree diagrams and calculating or not calculating, listing out the total possible number of outcomes, the different ways that we can generate our results by picking different things in our tree diagram. So that's what we did last lesson. Today we're going to look at 5 more problem solving questions over here. So I have here question 22, 23, 24, 25, and 26 on my screen over here on, I don't know what side it is, on the other side. No, this side over there. And so I want you guys to do the 5 questions first. So do it on your own, pause the video and work on all the questions first. And then when you're done, continue watching for the solutions. So pause the video now. So I assume that you have already done the 5 questions. If you haven't, please go and do them now and pause video, or else you're not going to get too much out of this lesson. So first of all, question 22. So it says here that you randomly choose a mug from the shelf below. Let's go ahead and see what kind of choices we can get for choosing mugs once and then second time without replacement. So first choice, I'm going to draw a tree diagram. First choice, I'm just going to write first and then second down here. I can get a red mug. That's a possibility. I can also get a blue mug, and I can get a white mug. So those are my 3 possible results from choosing. And then if I chose the red mug the first time, that means there's no more red mugs, which means that I can only choose a blue or a white mug after that. And then if I chose a blue mug, let's just say I chose this one, I still have 3 different choices. I can still choose red or blue or white. Same as the white one. If I chose a white one the first time, I still have a red one, a blue, 2 blue ones, and a white one, which means that I have all 3 choices, red, blue, or white, which means that all of my choices will be RB for the first one, red then blue, and then red then white, and then I can choose blue red, I can choose blue blue, I can choose blue white, and then I can choose white red, I can choose white blue, and white white in the end. And so which one represents all of that? Let's go ahead and see how many there are first. So there's 1, 2, 3, 4, 5, 6, 7, 8 results. Which one has 8 results over here? Definitely not A. 1, 2, 3, 4, 5, 6, so not C. 1, 2, 3, 4, 5, 6, not B, which means the correct answer will be D over here. And let's see if it matches. So RB and RW, RB and RW, and then we have WR, WW, and WR, WB, and WW, and so those 3 are correct. And then we have BR, BB, and BW over here, and so the correct answer is D. Question 23. A bakery offers blueberry, cranberry, bran, corn, chocolate, and carrot muffins. So how many different types are there? There's 1, 2, 3, 4, 5, 6 different types of muffins. And so a muffin is randomly chosen and eaten from a bag with 1 of each muffin. So in that bag, there's 6 muffins, 1 of each. And so it asks us if a first muffin is randomly chosen and then you ate it already, and then you go and choose a second one, it says make a tree diagram first. So let's go ahead and make a tree diagram. So the first one we can choose, let me do it in sideways. No, I'll just keep it this way. So first one, we can either choose blueberry. So I'll just do blue, BB for blueberry, cranberry, CB for cranberry, and then the third one can be bran, just BR for bran, and then we have corn, we have chocolate, CH for chocolate, and then we have carrot, so CA for carrot. Okay, I'll just keep to 2 letters each. Okay, so blueberry, cranberry, bran, corn, chocolate, and carrot. So these are my first choices, 6 different choices. And then the second one, if I chose the second one, if I ate blueberry the first time, can I still choose blueberry the second time? No, because it's gone already. So we only have the other ones left. And so from here, we can only have cranberry, we can have bran, we can have corn, we can have chocolate, and we can have carrot. That's my choices for the blueberry. If I ate cranberry the first time, then I can still have blueberry, I can have bran, I can have corn, I can have chocolate, and I can have carrot. If I chose bran the first time, then I can have blueberry, I can have cranberry, I can have corn, I can have chocolate, and I can have carrot. If I chose corn the first time, then we can have blueberry, we can have cranberry, we can have bran, we can have chocolate, we can have carrot. And then if we chose CH, which is chocolate the first time, we can have cranberry, we can have blueberry, blueberry. Oh, I missed blueberry the first time. So blueberry, then we can have cranberry, then we can also have bran, we can have corn, we cannot have chocolate anymore, and then we can have carrot. And then last one, I know I'm running out of space over here. Then here we can have blueberry, we can have cranberry, we can have bran, we can have corn, we can have chocolate, and that's it. Okay, so that is our tree diagram. I know it looks very complicated, it looks very messy, but that's just how it is with so many choices. And so let's go back to our question over here, and it says, make a tree diagram showing the ways two muffins can be chosen. What is the probability that at least one of the two has berries? So what are the two that has berries? What are the berries one? There are cranberry and there's blueberry. So we need to go ahead and circle or highlight the ones that has berry in it. So over here we have these all have berry, these all have berries in it, because there's at least one of them. And then over here, so each one of them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 choices so far that has berries in it. And then after that, bran and blueberry, if I chose bran the first time and blueberry the second time, it still has at least one berry. Same for cranberry over here, and the rest, no more berries. And then over here, same blueberry and cranberry, blueberry and cranberry, blueberry and cranberry. So we need to count the total number of possibilities that contain at least one berry in it. And so there's 10 plus 2 plus 2 plus 2 plus 2, which is 16 in total. So let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh no, 17, 18, because it's 2, 4, 6, 8. Yeah, so it's 18. Sorry, 18. So our favorable outcomes, the probability of at least one berry, okay? At least one of the two muffins has berries. Yeah, so at least one berry type of muffin, that will be equal to number of favorable outcomes will be 18 out of how many total possible outcomes? That's 5, 10, 15, 20, 25, and 30. So there's 30 total possible outcomes. So this is our fraction. We can reduce it to what's 18 over 30 in reduced form. That's going to be 3 over 5. So that's equal to 3 over 5 in fraction. And then in decimal, that is the same, or percentage, that is the same as 60%, or 0.6 as a decimal. I'm not sure if you guys can actually see all of that. Yes, you can see it. Good. So that is question 23. So first we drew the tree diagram, and then we calculated the probability afterwards. Okay, so next question, question 24. Question 24, and let me just move my question down here so that it's next to it. Forget all the previous markings from up here. So let's look at question 24. It says cheerleaders who do stunts are called flyers, and a coach has chosen the right outside flyer and the left outside flyer for a stunt from the squad's 5 flyers: Anne, Mandy, Zoe, Laura, and Janie. So there are 5 girls who are able to do stunts, can be flyers, but only 2 of them will be chosen. And so make a tree diagram showing the ways that the 2 flyers can be chosen. What is the probability that Mandy and Laura are not the 2 flyers? And we have to explain. So it doesn't matter whether we choose one first or the left first or the right first. It doesn't matter. I'm just going to start with the left over here. So for the left flyer, LF, what are our choices? We can choose Anne. I'm going to say A for Anne. And then we have Mandy, M for Mandy, Z for Zoe, L for Laura, and J for Janie. So those are our 5 possible choices for the left flyer. And then for the right flyer, if the coach chose Anne the first time, she cannot be both the left flyer and the right flyer at the same time, which means that there's only 4 possibilities left. So 1, 2, 3, and 4. It can be Mandy, it can be Zoe, it can be Laura, or it can be Janie. Janie. Interesting name. And then if Mandy was chosen the first time, then it can be Anne. Anne can be chosen the second time. We can have Zoe, we can have Laura and Janie. And then if Zoe was chosen the first time, then our 4 possibilities can be either Anne, it can be Mandy. Is it Mandy? Mandy, yes. And then Zoe cannot be chosen again, so it's Laura or Janie. And then after that, if Laura was chosen the first time, then the second time we can have Anne, we can have Mandy, we can have Zoe, or we can have Janie. And then the last one, if Janie was chosen the first time, then the second time it could be Anne, Mandy, Zoe, or Janie. So here are our outcomes. So all the possible outcomes can be either we can have Anne plus Mandy, we can have Anne plus Zoe, we can have Anne plus Laura, or Anne plus Janie, we can have Mandy plus Anne, we can have Mandy plus Zoe. Oh, what happened to all my lines over here? We can have Mandy plus Laura, we can have Mandy plus Janie, and then we can have Zoe plus Anne, we can have Zoe plus Mandy, we can have Zoe plus Laura, we can have Zoe plus Janie, we can have Laura plus Anne, we can have Laura plus Mandy, Laura plus Zoe, Laura plus Janie, we can have Janie plus Anne, Janie plus Mandy, Janie plus Zoe, and Janie plus, no, not Janie again, that's Laura. Okay, so those are all the different possible outcomes for left and right flyer. Now you may be wondering, is A and M the same as M plus A? They're not the same, because if Laura is at the left side, if Anne is at the left side and Mandy's at the right side, there is a different outcome that maybe Mandy's on the left side and Anne is at the right side. So they're not the same. So now let's look at the question again. It says, what is the probability that Mandy and Laura are not the 2 flyers? Are not the flyers. So we have to choose all the outcomes without Mandy and Laura. No M, no L. So which one is that? There's M over here, there's no M or L, there's L over here, there's no M or L, there's M, Z, A, there's no M or L, there's an L here, there's an M here, there's an L here, no M or L here, there's an L, and then J, A, there's no M or L, J, M, yep, J, Z, no M or L there. So 1, 2, 3, 4, 5, 6. There are 6 outcomes in which Mandy and Laura, what is the probability that Mandy and Laura are not the two flyers? Oh, it's Mandy and Laura, not Mandy or Laura. Sorry. So I think, yeah, the question made it a little bit confusing. I'm sorry. It says Mandy and Laura. Okay, the probability that Mandy and Laura together are not the two flyers. It didn't say left or right, so we're just interested in Mandy and Laura together being the flyers. And so which ones are that? I don't think I can I undo all of my yellow highlights? Yes, I can. And so instead, I'm going to highlight it again. This time it's both Mandy and Laura. So we want ML or MLM. So which one is ML over here? This one. And then we want LM, which is here. That's two possibilities. And how many total possibilities are there? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 different possibilities. And so the probability, let me just write it over here, probability that Mandy and Laura are not chosen is equal to, there's only 2 are not chosen. So there's only 2 possibilities in which they are chosen together. And so the ones that are not chosen is going to be 18 possibilities out of 20. Okay, so make sure we understand the question. Mandy and Laura chosen will be 18 out of 20. So it will be 2 possibilities. And so if they are not chosen, that's going to be 18 out of 20, or we can reduce it to 9 over 10, or that is 90%, or 0.9. Okay, so that's question 24. Let me speed up 25. You roll 2 number cubes. So you roll 2 number cubes over here. 2 number cubes standard dice. Okay, just standard dice. And so we want to find out, is it more likely for one of the 2 of the numbers to be 2, or for both of the numbers to be odd? So either ways, we're going to have to draw a tree diagram. I know it's going to be very complicated because there's 6 numbers. And so you have 2 number cubes. So the first number cube, how can we do it so that it's not messy? Let me try my best to make it not messy. I'm going to zoom out. And so my first row, that's my first number cube. I can either have 1, I can have 2, I can have 3, I can have 4, I can have 5, and I can have 6. So that's the first row that I can get. That's the different combinations that I can get. And then from the second row over here, let me just go down a little bit more, second row, so that I don't squish too much. And let me just try my best to separate it so that I have equal spacing between all of them. So that means from here, I can roll 1, 2, 3, 4, 5, 6 for number 1. I can roll 1, 2, 3, 4, 5, 6 for number 2. I can roll 1, 2, 3, 4, 5, 6. I can roll 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Each one of them, I can draw my tree diagram this way. And lastly, 6. So let's look at the question again. It says, what is it more likely for exactly one of the numbers to be 2? So let me highlight one number exactly. One number is equal to 2. Let me highlight that in yellow over here. Exactly one number is equal to 2. Which one is that? We have 1, 2 over here. So this will be one number 2. And then we can also have 2, 1, 2, 3, 2, 4, 2, 5, 2, 6. All of these have exactly one number 2. And then we can have 3, 2. We can have 4, 2. We can have 5, 2. We can have 6, 2. So all of those are exactly 1 2s. And how many of them are there? Let's count the number of highlighted yellows. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 10 possibilities. 10 possibilities. And then the next part is or for both of the numbers to be odd. Both of the numbers to be odd. So which one? Both of the numbers to be odd. So both numbers odd. I'm going to highlight that in green. So which ones are both numbers odd? 1 and 1, 1 and 3, 1 and 5, those are both numbers odd. 2 is already even number, so we can skip all of 2. Then we have 3, 1, 3, 3, 3, 5. We can skip 4, 5, 1, 5, 3, 5, 5. And we can skip 6. And how many possibilities are there? There's 3, there's 6, and there's 9 possibilities. 9 possibilities. I spelled it wrong. Possibilities. And so we now compare which one is more likely. And so which one is more likely? The one with a bigger possibility. So 10 is bigger than 9. So exactly one number is equal to 2 is bigger possibility. Bigger possibility over there. Now I know my video is going over 20 minutes, so I'm going to stop here. I'm not going to do question 26. Hopefully you guys have done it. Maybe I will do it in the beginning of next lesson, and I will end my lesson over here. Goodbye.